Okay, first what we'll do is we'll probably just go ahead and write some code. You may or may not understand that code, but that's not important. That's really not important. What's important is the concepts behind it. If you have some background in Java or some background in Spring Boot, you will be able to follow almost everything. So that's good enough. But in general, concepts should be gotten by everyone. So what I'm going to show you is I'm just going to show you some very simple classes. Okay. Let's say there is a class, very simple class called as pizza. Now, do not worry about these things. These are called as annotations. In Java, they are called as annotations. If you do not know what annotations are, do not worry. Do not give a damn about it. So let's say there is a class called as pizza, and this class, it contains an instance variable. Every class can contain instance variables, right? So basically it depends. So when you look at pizza in general, when you look at pizza, you can say if there is a class called as pizza, then it will have several attributes inside it. For example, pizza can have a topping on top of it. So let's say the topping is of corn, right? Let's say there are some corn topping on top of it. So I can just go on and say it has an instance variable called as corn topping. Now, in general, whenever this situation is, if you have to create an object of pizza, how do you do it? You call constructor of pizza and then you inject corn topping object inside it. I mean, that is how it works, right? So I'll just quickly illustrate it. So how do you go about it? You say that, yeah, you use a new keyword. That's like calling constructor. You say public pizza, and this constructor takes an instance of corn topping, right? And then you just do this dot corn topping equals to that topping, right? And it is important. It is important for us to pass this corn topping while creating an object of pizza. Why it is important is because if you want to invoke this method, if you want the functionalities to work, the methods to work, like here, this is the method, and if you want it to work, you want this thing to be initialized. If it is not initialized, it will be equal to null and you will get a null pointer exception, right? So we all have seen such kind of code. We all can just go here and we can just do new of pizza and we can inject new of corn topping, right? Let's have a look at this corn topping class. It's a very simple class and it has a string variable corn topped pizza, and this is the name. This is the get name method. When you call get name for an object of this, you will get this name corn topped pizza. Okay. And if you look at this class, when you call get name, you will first get this prefix wheat base followed by the corn topping name. So basically the result should be wheat base followed by corn topped pizza. That is the result which you should expect to see. So now if I go here and this is an instance of pizza, so I can just store this inside variable p, and here I can just do system.out.print p dot get name, right? And if I run this piece of code, then this is the result that we are getting. And this is expected, right? Wheat base corn topped pizza. So all of you know how it kind of worked, right? First, it printed the name prefix, which is nothing but a static string, wheat base, correct? And then it made a function call to get name of corn topped, right? And there it printed corn topped pizza. So this is the entire thing which got printed, right? All of us are familiar with this piece of code and all of us follow this convention for creating objects and invoking methods, using them basically, right? But now, if let's say I remove this piece of code for a while, go here, remove this constructor, okay? And then I do context dot get bean. Okay, do not worry about what this function and all is. Just hold on for a moment. And then I store this inside a variable, let's say pizza p. It will need me to do typecasting. So I'll basically typecast it into a, all of you would know basics about typecasting the variables, right? Into integer and all. So it's just like that. Now here, if you do system dot out dot println p dot get name, okay? Now let's run this piece of code. You can see still it ended up printing wheat based corn top pizza. Now this is where, if you are learning it for the first time, if you're learning a framework like Spring Boot or Juice or anything for the first time, this is where you should, I mean, you should be in awe. You should feel like, hey, what, how does it work? The creation of an object of pizza, it requires me to make a constructor call, right? It requires me to make a constructor call. Previously, we had a constructor, so we called that constructor and we injected inside that constructor an instance of corn topping, and that is how it worked, right? But in this case, how is it that the things are working for us? Now, so one of you is replying default constructor call. Default constructor call cannot initialize this particular field. When you say default constructor, the default constructor is usually your empty constructor. It is no args constructor, right? The fact that this function has worked, the fact that this function has worked and printed the right result, it means that corn topping has been injected inside the constructor. It means that somehow an object of pizza, an object of pizza has been initialized, and this object internally it contains another object which is called as corn topping. Who did it for us? Who did it for us? Because we didn't do it. We did not, I mean, in the previous iteration of code, we were the ones who were doing it. We were doing new of pizza, and inside that we were doing new of corn topping, and it was working well. But here somebody else has done it for us. This is where the dependency injection property of Spring Framework comes into picture. So what is the meaning of dependency? So all of us understand, dependency means something that you are dependent on, right? Now, if you look at this particular class, if you look at this class, I can say here the dependency of this class is corn topping. It is dependent upon corn topping. Corn topping could be dependent upon some other class. So in the object-oriented world, there is actually a dependency graph of objects. There is that dependency graph. Like to give you another example, let's say there is something called as a shipment. Let's say you are building Amazon or e-commerce, something like that, and you have created a class called a shipment. Now a shipment can have multiple fields inside it. So a shipment class could contain an object of maybe address, right? It could also contain order. This address can further contain two things: billing address and maybe shipping address. This order can contain a lot of details like order ID, the items. So basically, if you look, it's going to be a directed acyclic graph where this particular thing, in order to initialize an object of this class, you need this object to be ready. And for this object to be ready, you need this, and that to be ready. For this to be ready, you need these, and those to be ready. So in object-oriented world where we have objects, we have this dependency. And the reason these dependencies exist, so we have to do dependency injection. And how do we do dependency injection? By making constructor calls. And whenever we call constructor, we pass the dependency inside it, and that is how it works, right? But this very process of initializing the objects in a boilerplate manner. Boilerplate means it is nothing interesting. It's quite boring. I mean, you know that in order to create one object, you need instances of two, three other objects. And in order to instantiate those two, three objects, you need more objects. So that way, you will end up creating chains of new, 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 new. And that's not anything creative that you are doing. If there were some framework that does it behind the scenes for you, then it would be amazing, right? So just imagine, yeah. So let's say if you had to ever instantiate a class A, and let's say the constructor of class A, it required B and it required C. Now this B further, it required D, and this D further, it required E. It's very much possible, right? So dependency injection is a property of frameworks like Spring Boot, frameworks like Juice, which avoids you from getting into all such sorts of nonsense. Something else takes care of it. Spring takes care of it. So now I'll tell you these signals. These signals, I mean, I mentioned a word, I told that these are annotations. So these annotations are just like signals which you provide to Spring Framework. So Spring Framework gets to know that, okay, there is a class called as pizza and user is not going to create an object of it. Because user is not going to create an object of it, so I am the one who will be creating an object. So what Spring does is it literally creates an object of it, and how it creates, there are ways to create an object of something without constructor call also. In fact, using reflection. So many of you might not know what reflection is, but okay, that's not needed. We really need not know about those things. I'll tell about that in surface level so that, I mean, wherever it is required. But using things like reflection, Spring Boot can create an object of it. It can also create an object of it, and then it can inject this inside it. What is the use of this auto-wired keyword? Auto-wired is another signal to Spring which tells it that, hey, this pizza needs to be auto-wired with corn topping. So create an object of corn topping and put it inside pizza. Then only pizza is ready to use. Otherwise, it is not ready to use. Okay, so that's the idea. Now, if you look at this code, before executing this and that, yeah, if you have studied a reflection concept, yeah, it's there on our platform also. So if you have studied, you will be able to, kind of follow that what Spring does behind the scene. I'll show you the code. I'll show you the code of a mini Spring. If let's say we have to write our own dependency injection framework, a mini dependency injection framework, how would we go about it? And that would clear a lot of concepts. Okay, so this line of code, what it does is when you say spring application dot run, it literally runs the Spring framework behind the scene. And when Spring framework runs behind the scene, it checks that, hey, which classes are annotated with at the rate component. So it sees that, okay, this is annotated with at the rate component. It sees that, okay, this is annotated with at the rate component. So first it sees that, hey, there is something called as corn topping. So corn topping is a node. Imagine it is a node in the graph. And then further it sees that there is something called as pizza, right? This pizza. Pizza is also annotated with at the rate component. So this is another node. Further, it sees that inside pizza, we have used an auto-wired keyword and we have said that pizza is auto-wired with corn topping. Now that gives it a signal that this depends upon that. So that is how it gets informed about this edge. Now let's say if pizza depended upon something else also, let's say anything, let's call it X, then it would have understood that. Now let's say X depends upon something called as Y, and even this depends upon Y. So this is the object graph which Spring Boot understands. And then how do you traverse a graph? Do you know about some graph traversal techniques? A lot of you were talking about DSA. So yeah, BFS and DFS, right? So the first thing that the framework does is it performs traversal of this graph. It literally traverses it, and as it is traversing it, it builds these objects on the go. So how it builds these objects? The Spring framework says that, okay, let me start from pizza. But then it realizes that, hey, I cannot make a pizza. Why I cannot make pizza? Because X and this, both of them are not ready. So now it'll jump from here to here. It'll go to X, right? And then it'll realize I cannot make X also. Why I cannot make X? Because this is dependent upon Y. So now it'll go to Y, and then first it will create Y. When Y is created, then the control comes back to X, and then X will be automatically created. Now the control goes back to this, and it again realizes I cannot create this because CT is not ready. So control comes to CT, and now it realizes that, hey, because Y is ready, so CT can be made ready. And now once CT is ready, X is ready, now P also can be created. It's classic case of, DFS and backtracking, where you make recursive calls, and when the control comes back to the parent function, you realize that, okay, the children have been created. And if they have been created, you create parent, and the control goes to the parent of parent. Does that make sense? Its internal application is graph-like structure. It's not about internal application. It's a very generic thing that I said. It's about the world of objects. If you are writing code in any object-oriented programming language, you create classes and objects and all that, it naturally is a graph. So any framework that you use that will interpret it as a graph, and in order to perform dependency injection, it will just traverse that graph and initialize things on the go, and that is how it will kind of go ahead. Yeah. If this happens, then is it redundant when we initialize object like you defined pizza? You do not always use Spring Boot, my dear friend. Lot of times you just write simple standalone Java application. On lead code, do you integrate Spring Boot and write code? No, you don't do that. You use frameworks only when you realize that you have to really write a production grade code where so many components will be there, maybe a web application or an app or something like that. And there you want to put your head on writing the business logic, on the core algorithm, the core logic. You do not want to put your head on initializing the objects, writing a lot of new. You don't want to do that. That is where you use frameworks like these, and that is where you do not need to explicitly call constructors. Yeah. Will it create another object of? That's a good question. That's a very good question. We'll talk about it. But for now, I'll tell you one thing that you might have heard of a keyword. I'm not sure how many of you. It's quite famous. Have you heard of something called as singleton? What is singleton? Singleton means one and exactly one. One instance of something is called a singleton, right? So by default, Spring creates singleton objects. So what it means is that if there is a class called as corn topping, it will create exactly one object of corn topping. So it will create exactly one object of corn topping. Now let's say there is some class, call it A. And if A is dependent upon this, and then there is another class B that also is dependent upon this. So it's the same instance of this, which will be injected inside this and inside that. It's the same instance basically. By default, it is singleton. By default, it is. Okay. So, okay. So I think that has, okay. Final thing. Usually when people go after learning Spring Boot, they immediately start hearing word like beans and all. And this very word leads to a lot of confusion because they do not understand it that bean is nothing but an object which is created on your behalf by Spring Boot. That's it. That's it. So what is a bean? Bean is nothing but an object which Spring Boot created on your behalf. And how it created that, we have just discussed it. We will also see an implementation of it. But then we kind of understand, yeah, bean is singleton. I mean, again, You do not need to disambiguate between the objects created by Spring Boot and Bean. Any object created by Spring Boot, in fancy terms, it is called as Bean. That's it. You want to call it Bean because the entire community calls it Bean. But I mean, that's the thing. So now, um, yeah, if you look here, this context, application context is like a container of beans. Okay, it's like a container of beans. It contains so many beans inside it. And what are those beans? Those beans are the objects. Now you can request this container, hey, please get me this bean that you created. So this function, when you are calling, you are saying that, hey, Mr. Application Context, get me a bean, pizza, whose name is pizza. So it returns you that, you typecast it, and then you play with it. That's it. So it's like pre-processing. When this command runs, the Spring Boot pre-processes, scans your entire code base, finds out that which classes are annotated with @ component, which class requires which dependency, creates that entire thing and loads that application context, that huge application context for you. And now whenever you want a particular bean, you can simply invoke this method and get that bean and work with it. That is one way. Another way is that if you want to write a class, let's say right now you have this class. Now, if you want to write some other class, if some other class, let's say coffee, you want to write a class called as coffee. There is no topping of corn on coffee, but let's say you write a class called as coffee, and you can auto wire that class to contain an instance of corn topping. You can do that. When you auto wire, Spring takes the responsibility of injecting it, and you don't need a constructor in that case. So that is how it kind of works. See, in C++ also there would definitely be frameworks like these which are written in C++. Spring Boot is written in Java. I mean, its source code is written in Java. So it is a Java framework and it's basically used by Java developers. In C++ also, I'm pretty sure you will have something written which would take care of dependency injection and all. There is a framework called as Juice, Google Juice, Guice. How many of you have heard of it? So you can just check if it has a variant in C++ or not. I think it has one in Java, but you can explore those things later, whatever it is. Okay, now let me show you some code. See, this class is just an attempt from my side to help you understand that whatever I spoke is not a theory. It really happens. And if the Spring Boot community of developers did it, you also can do it. Okay, you just have to sweat out a lot, put a lot of efforts, but you can do it. This is very simple example that I'm giving you. But even if you want to build a production grade app, dependency injection app, then you can do it if your fundamentals are clear. So see how we are going about it. You know what I have done here is, this is a simple main function. It's a standalone Java application. There is no Spring Boot in this. Let me tell you that there is no Spring Boot inside it. It is a standalone Java application. Now there is a folder called as beans. Inside this folder, there are a lot of classes. Like there is a class called as converter, you can see. And then there is a class called as DB accessor. Then there is a class called as logger. I mean, there are different classes. So basically there are so many classes inside this. And why I have created a separate folder called as beans is because I want to demonstrate it to you that if I have to write a code where I want to manage all these objects, I mean, how Spring Boot gets a signal is that Spring Boot looks after annotation. It checks that, okay, does this class have this annotation? Does that class have that annotation? It checks those things and then it realizes that, okay, these are the beans that I have to make. In this case, I'm not using annotations because if I use annotations, I'll have to probably talk about annotations. Things will get clumsy and you will get tired. So I'm just taking an assumption that let's say there is a folder called as beans. Inside that folder, somebody has created a lot of classes. And now my framework should take the responsibility of creating these objects and auto wiring them and taking care of everything that needs to be taken care of. Okay, so how to do that? So let me show you something. Now, okay, it's not about the code. Again, it's about the experience of it. So I'll explain you what happens where. So you can see I have invoked a method called as find classes. So let me explain what this method does on a high level. So here you pass a package name. Okay. Now here in this beans, the package name is going to be this Spring Bootcamp dot reflection dot bean register dot beans, right? So if you look here, that is exactly what I have passed. I have passed the package name. When I have passed the package name, my intention is that, hey, this particular function, Mr. Function, what you're supposed to do is inside this package, whichever classes are there, return me those classes. Just return those classes to me. Just tell me that there is a class called as converter, there is a class called as DB accessor. Just tell me that. So that is what it does on a high level. Okay. Now, after that is done, we create something, a hash map of string to object. Now I'll tell you why I have chosen a hash map and what is it. So this is what my container is. This is pretty similar to that application context thing that you saw there. This is my container of beans. Now inside this, for everything, so let's say there is something called as logger. So in this map, there will be a key called as logger. And corresponding to that, the value will be literally some logger object. And if that is the case, it will be very simple for me to access an object. I'll just have to do registry.getLogger and I will get the corresponding logger. This registry is nothing, it's just a hash map. Hash map of the name that you want to give to that bean and the actual bean, the actual object. So what I have to do is I have to initialize this thing. I have to initialize it. Okay. For a moment, what we'll do is we'll just look at all the different classes that are present over here. So I would say, see, the first class over here that you can see is something called as request dispatcher, right? So there is something called as request dispatcher. So let's draw it here. There is something called as request dispatcher. This request dispatcher, it depends upon another class called as web API. So it depends upon something called as web API. All right. Um, Now let's look at web API. Web API depends upon DB accessor and logger. So this web API is depending on DB accessor and logger. Did we use Spring Initializer? No, that is what I told you. This is a standalone Java application. In this application, there is no Spring Boot used. Okay, this is just to conceptualize things. Okay, now if you look at DB accessor, DB accessor is depending on logger. Okay, all right. So that makes sense. DB accessor is also depending upon logger. Okay, and what else? And yeah, let's also look at logger. What does logger depend on? Logger depends upon something called as my file reader. All right. So logger depends upon file reader. Okay. So I think we are done with all the classes. Yeah, I think we kind of missed out on one class, and that is converter. This converter is alone. So, in graph also some nodes can be alone. So this converter guy is all alone. So let's write converter over here. This is literally a graph, a directed acyclic graph. And now the challenge posed by me is what I want to do. I just want to focus my attention here and I want to initialize all these beans. All these beans I want to initialize and I want to put inside this hash map. So I want to put converter points to a converter object. DB accessor points to a DB accessor object. So that is the challenge in front of us. Now, let's see how do we embark upon it. So I have written a method initialize beans and let's see what this method does. I mean, if you really look at the code And if you have ever written DFS, if you have ever written DFS, you will realize, oh my God, it's just a proper code of depth first search. It's just DFS, nothing else. Okay. So what we are doing here is, this is the set of classes which we found out inside this package. So we iterate on all the classes, and for every class, there will be some name. For example, let's say there is a converter class. When you do c.getName, it will return you converter. This is how reflection works. This is reflection. Okay. But put it at the bay for now. You get the name of the class. And once you get it, you check whether that is there inside your map or not. Because if that is there inside your map, that means you must have created an object of it. If you had created an object of it, then you just inject it wherever it is needed. Like for example, if you focus your attention here, let's say when you were at this particular node and you realized that this needs this, and then you realize this needs this, and then you realize this needs this. So you would have created this file reader, and then you would have created logger, and then you would have created DB accessor. Now when the control comes to this web API, you realize that web API needs a logger. At this point of time, you would find out that logger is already created by you. Logger was already created when you wanted to create this object, and now the same instance of logger, the same logger object can be injected inside this also. That is what I meant by singleton bean. And that is what is written over here. So this line of code is actually saying that if you ever created this particular object, and if it is being needed by something else, maybe the converter needed it, or maybe something else needed it, then you do not need to recreate it. Just use it as it is. You do not need to create that. That's the basic idea. Is that making sense? All right. Cool. So now once we understand this, we can go ahead. Now you can see that only if we find out that a node has a dependency which is not yet created. So let's say this this RD that you are seeing here, let's say it depended upon something called as X. And if an object of X is still not created, then we need to create it. And how do we create it? We create it by, okay, again, this is not a project. I mean, it's a standalone Java application. It's literally a main function, guys. I'll show you again. It's a main function. So no matter which ID you use Eclipse, you use IntelliJ, you can put this entire code, copy paste this entire code there, and it will work. It doesn't require you to put, if you have basic JDK, it will work. It's, yeah, that's very well put. It's just a, not stimulation, simulation. It's a simulation of how Spring works. Yeah, that's very well put. Okay, so coming back to this, only if we realize that there is a dependency which is still not created, then we go ahead and create it. So how we create it? This is again via reflection. So you know the class, and when you do dot get constructor dot new instance, it somehow instantiates, it somehow creates an object with empty fields or null fields inside it, right? So, okay, I'll explain what it typically does. So let's say RD had dependency on X, okay? And X depended on S and Y, let us say. So you'd have seen that, hey, here, this X has not been created. So let us create it. So you'd create an object of X using this line. When you create an object of X using this line, these two fields would be null. So you need to inject these two fields, right? You need to inject these two fields inside it. In order to do that, you create this method called as inject fields. So now we call a method called as inject fields, and this method will take the responsibility of injecting S and Y inside this X. And now this method will be recursive. Why it will be recursive is because, let us say S depended upon P and Q. If S depended upon P and Q, you'd have realized at S that, hey, before I create this object, I need to create this and that. And with the same logic, if you, let's say, go after creating P and you realize it needs M and N, you'd then go after M and N. So it is going to be recursive in nature, this inject fields method. So let us have a look at it. See here what we do. Let's say you called inject fields on X. We got to know what is the class type of this X, right? And then we fetch all the fields that are there inside it. See, this line is quite important. So if you're looking at this X, the fields of X is S and Y. So this is literally going to return you S and Y. I'm just putting it in comments, S and Y. Now you iterate on all the fields because you know that X cannot be created until S and Y are created because S and Y are the dependency. So now you iterate on S and Y and forget about this check for now. Let's not get into that much detail. Now what we do here, we check if S is already created or not. If let's say S is already created, it could be possible, right? So let's say there was some class C which depended on S, and when you created C, you also created S. So if that S is already there, we can use it as it is for this X. So that is put over here in this particular line, where we are saying that if the registry already contains this, then we are simply going to set the same field inside it. And if that is not the case, then we come to the else part of the code. And what do we say in the else part of the code? Same thing. That, hey, because S is not created, let us get the type of S, whatever it is, and then let us create an empty object of it and recursively call inject fields on S. So if you realize, here we had invoked inject fields on X. That in turn invokes inject fields on S. Now, when inject fields on S is invoked, the same set of things will happen. You will realize that S has fields which are P and Q. And when you iterate on P and Q, let's say when you are at P, you realize that, hey, P is not created. It is not present in the registry. So now you will go after creating P. When you create P, you will inject fields for P. So now the control comes to P. And then the control comes to M. And that is how it goes. So it's literally a DFS which is happening. And in this DFS mode, you will end up seeing that the entire objects, all the different objects that are there would get created, not just created, but also after getting created, they would be stored inside this registry. And now you can see what I am finally doing is I am iterating this hash map and I am printing the key value pair. So key will basically be the name like logger and value will be the fully qualified name of that class. So that is how it kind of works. P and Q can be of primitive types also. They can be primitive types. It's totally okay because eventually, all types are primitive. All your leaves are primitive, right? So int, or even if something is a string, its primitive type is a character array, right? Where everything is character, character, character. But yeah, the basic idea is that this is how it kind of works. You do not need to understand the full code. You just need to understand the idea of how dependency injection works. Is that making sense? So we will run this code. We can just hit run over here. Web API is just a random class. I could have named it Tom, Dick, and Harry, anything. I mean, it's just a random class. See, it's just a random class which has some dependencies inside it. If you would have made the class themselves singleton, we would need to check the client. See, you do not make the class singleton just like that. You code it in a way that it is singleton. How you code it in a way that it is singleton is you make the constructor private and all that, and then you write a static method. So that is a very different thing. Okay, this is very different that I'm talking about. So here, Spring just takes care of the fact that an object once created, until unless the user has said that I want multiple instances, it doesn't create multiple instances. If you want multiple instances, there is a way to do that. You can request the Spring to do it for you. Maybe two objects, or for every session, for every request new object, all that can be done. But again, like you can go on to that later. How much time to code? Literally, I mean, not much of time. Okay, so if you have to write this piece of code, I mean, when I was writing it for the first time, of course, I was writing it before I had to take a class. So I took maybe around 1 hour or something to write it. But if you have to write it and you're fluent, should be able to Probably do it in half an hour or 45 minutes. If you are clear with the idea of DFS, you'll be able to do that. So I think I just ran this code and you can literally see what happened, right? So you can see that this is the name of the class. So, I mean, this is the output of this particular line. Yeah. So the name of the bean is DB accessor. And this thing, the hash code, can you see this hash code? This is hash code. In Java, every object has an hash code. So when you print an object, it's hash code and all that gets printed at the rate something, 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 some random garbage kind of thing. So that is what has got printed. And you can see everything got printed. DB accessor, my file reader, logger, converter, web API. Everything got printed. Okay, cool. Now tell me, will this uh, logic work if there are cycles in the object graph? Let's say class A depends upon class B depends upon C depends upon A. It will not work. And even while building a Spring project, if you create a component A which depends upon B, and let's say B again depends upon A, Spring will throw an error. Have you tried that out? Or have you experienced it ever? Yeah. So that error is just because of this fact. Because you cannot fulfill all the dependencies if there is a cycle, right? So it's very important that your object structure, your class structure should be such that there are no cycles inside it. Of course, if by any chance cycles have been introduced, then that's a bad design. I mean, that's a stupid design, I would say. I mean, that's a mistake. Not even stupid design, that's a mistake. That's a bug. So that needs to be resolved. Um, okay, all right. There should always be a leaf. Of course, naturally. I mean, everything terminates at some point of time. I mean, a class depends upon some other complex class, then that class, if it depends upon some other class, finally something has to depend upon integer floats and character and all that. That's how it goes. Yeah. Okay. So with this, all of you should now have a great idea of what is dependency injection and how it works.